this really gets back to what you observed when you did ESL, that computers were not just a better version of X, that it was a disruption and a offset about, back then, direction finding and other intelligence systems. And now you had a national stage to kind of play this out on. What technologies did you see and choose, and why? And we talk about sensors and stealth and precision weapons. Were those already ongoing? Did you select them? How did you invest? What did the status quo think? This must have been a heck of a time.
It took me about 3 months to come up with what the offset strategy would be. I mean, it's one thing to say we're going to use technology.
3 months?
But the question is how we're going to use it. One of the things we decided right off is we had to make our weapons smart. What do we mean by that? Well, during World War II and during the Korean War, when we dropped bombs or fired artillery shells, we never knew exactly where the target was. And so we had to drop 20 or 30 bombs, and we couldn't guide them accurately. So we had to drop 20 or 30 bombs for every target. And so we thought what we wanted was one bomb, one target, which would make a huge difference, not just in the accuracy of our work, but in the logistics tail that was entailed with it. So smart weapons was one part of it, and the technology that was available then led us to focus primarily on laser-guided bombs. So we built tens of thousands of we developed and then built tens of thousands of laser-guided bombs, which are still today a major component of our weapons. We needed to have a way of guiding things accurately, and the laser turned out to be that. We also had to have a better way of knowing where we were when we fired, if we were in an airplane. So we thought we'd better have a way of accurately positioning. So we developed a global positioning system, which is what we call GPS today. And of course, everybody uses it in an automobile or in a handheld navigator today. At the time, I wasn't thinking about the commercial applications of it, but the military applications of it were very obvious.
We're thinking about Yelp and GPS.
So we developed GPS at that time. And if you use it in your car today, you have me to thank for that. We also developed something called DARPANET, which later became the internet.
Wow.
And all of that was pretty straightforward and obvious applications of things we had been doing. No great leap forward in imagination, just leap forward technically. What was a leap forward in imagination was building an airplane that could not be detected by radars. Airplanes are a key component in military warfare, have been since World War II. And because they're so key, every country has developed systems for shooting them down that involve radars and missiles to fire at them. So surface-to-air missiles, which are guided by radars. So we wanted to develop an airplane that could not be detected by radars, and therefore they could be not shot down by missiles. And that became called a stealth. It's not stealthy in the sense you couldn't see it. If the F-117, the B-2 flew over and you looked up, it'd be quite obvious to you. But the radars couldn't detect it. And so they had complete impunity at nighttime. They could operate at night without any. So the stealth was a third component of those are the three major components. We decided on that in the first 3 months, and then pulled out all of our throttles to move forward. I wanted to have them done by the end of I don't want to stay more than one term in government, so I wanted to have them done in the 4-year period. Indeed, we had the first stealth airplane flying just before I left office and 4 years later, which is pretty unusual.
You don't get the paperwork done usually for 4 years in the government.